Welcome to the second last Easy Happy Hour for this year. We start a new series expanding the reach of EESSI, Kubernetes and Android. And today is about EESSI and Kubernetes, the CVMFS-CSI plugin. And I'm very happy that we have a guest speaker today, Davide Grassano from EPFL, and he will take over. And as I said before, so first Davide will present something, and then anyone can have questions to that. And you can also have other questions not related to the presentation. If you prefer at some point not to be recorded, ask something, then let us know, then we can stop the recording at the end. Okay, welcome, Davide.
Thank you very much. And good afternoon, everyone. So as you heard, today's topic will be expanding the reach of EESSI. So what we're trying to do is to get EESSI to run on different platforms than what we already support. And today's topic will be how to run EESSI or a proof of concept on how to run EESSI in a Kubernetes cluster. In particular, we will focus on the CVMFS-CSI plugin. This is a short outline of what I'm going to talk about, but I will jump right into it. First of all, this is not sure if you have already seen, there has been a blog post on this topic. This is a very small recap of stuff that will be relevant also for today's talk. In particular, the option 1 and 3 are relevant also to understand how the CSI plugin works under the hood for CVMFS. So, first of all, what is the problem you are facing when you want to use EESSI in a Kubernetes cluster? It is actually very similar to, I would say, to the problem of running EESSI in a distributed HPC system, with the additional complexity that you're not running on the bare metal, but you're running inside containers. So there are several options that you could use to make EESSI available to your cluster. Option number 1, you install EESSI directly on every node that you want to run EESSI, ideally everything on the cluster for simplicity, let's say. And then you can use similar to what you would do in Docker by mounting the EESSI directory to the container. In this case, we are using the hostpath mount to bound the EESSI directory to the pods. The pods are basically a group of containers if you're not familiar with Kubernetes. Option number 2 is less relevant for this talk, but what you can do is installing EESSI on a central node and then exporting it through NFS. But this, especially in a Kubernetes cluster, if you're running some nodes, for example, on AWS, some on a local cluster, it can be challenging network-wise. You might have to deploy multiple instances, and you might run into bottlenecks, or you will need to implement something like load balances for NFS and so on. Option 3 is you install EESSI inside the containers themselves, but this can both be challenging to manage because every time you want to upgrade something, you will need to upgrade all the containers, and it can also pose a security risk if users are allowed to start the containers on their own, or if they have shell access to the container they're starting, because this container will need to have sysadmin capabilities in order to access the fuse and mount EESSI. There are still some ways that you might be able to use to not give sysadmin capabilities to your containers, but you will still need to give them dev fuse access. And I think this could be, for many situations, probably a security risk. And as we will see, under the hood, this combines a little bit option 1 and 3, but removing a lot of the downside. The other way is to use the container storage interface plugin for CVMFS inside your Kubernetes cluster. And I will go more into the detail of it right now. So very, very briefly, what is the container storage interface? It's a standard for exposing storage system, either blocks or file or network, to containerize workload. This came about in order to abstract the way container orchestration system get access to various plethora of storages. Like you will get storage from a network file system, from your local machine, from AWS, from Azure, and either all the container orchestration system have to have the capabilities to support the storages in trees, so in their main code base and maintain it, or the container storage interface was developed exactly to abstract these exposing of the storage systems and make it available through plugins that do not need to be maintained by every CO methods, I would say. And very briefly, I want to go through the spec. I mean, if you want to know more about this, there are links on this presentation that will be made available, but there is the specification file for the CSI, a very nice talk that you can find on the 2019 version of FOSDEM, and the blog post and documentation of CSI is implemented specifically into Kubernetes. I will go very briefly to the specification file to show you how a plugin is usually structured to enable this. Basically, what this plugin do, they need to implement a set of specific gRPC endpoint that allow that tells then the container orchestration how to publish and unpublish volume, either at the controller plugin level or at the node plugin level. There are several ways in which you can deploy this plugin. The most common one is where you have a controller plugin that is run on a dedicated node, and a node plugin that is run on every node of your cluster, and it is the one that is responsible for actually provisioning your volumes. It is not always true. In some specific case, when the provisioning of the volume requires some specific admin privileges and you don't want even the node to see this, you can do this through the controller plugin, but this is not our case of what the CVMFS plugin is doing. So for this plugin specifically, but we will see more in details during the demo, it's basically, as I said, is structured in a controller plugin, which will actually contain two containers. One, which is the provisioner, which is a sidecar container straight out of the Kubernetes CSI implementation. And then there is a controller plugin that is the one that is responsible for doing the communication with the node plugins. And in the node plugin pods, there will be a register, which is also another sidecar container, which is responsible for just advertising the CSI socket to the node plugin, because it communicates through a Unix socket. And then there are four plugins, four containers that are responsible, one for managing the publishing and publishing on the node, and three containers that are responsible to actually expose the CVMFS storage to the system, and we will see how. So I would say let's jump right into the demo. And for this, I'm going to, let me know if you cannot see stuff or if it is too small. We can start by creating a Kubernetes cluster using Minikube. So in this case, I already had one existing, but I want to start this from scratch. So I'm going to delete this cluster very quickly. And I will pick up the GitHub repository where I published the demo, just because I don't remember all these commands by heart yet. So first thing we want to do is to create a cluster. In this case, we are using Minikube, which can create them both on Docker or on VM. In this case, I'm using Docker for simplicity, even if it adds some complexity in running the MPI stuff inside of it, but that's a different problem. So I'm starting a Kubernetes cluster with with one node, which is not specified, 4 CPUs, and then giving it 2 GB of RAM per node. And this is just to give a name to my profile. So here we can see Minikube is creating a Docker container. This container will act both as our control node and as our node. So it's basically a situation where you have a one node Kubernetes cluster and you run the control plane and the node on the same node as the only node you have. This is just for simplicity for me to run commands through Minikube. And first thing I want to do is to start the Minikube, the Kubernetes dashboard. You can do it easily on the Minikube through this command. And once the dashboard starts, okay, it should automatically open in that browser. I'm gonna make this a little bit smaller because we don't need the other side anymore. And As you can see now, this is a clean Kubernetes cluster. There is nothing running inside of here. In particular, because this will be created by the CSI plugin, there is only a one storage class, which is the standard one created by Minikube, which we don't really care about. There is no persistent volume claim. And here you can normally see everything. There is no pods or anything else running. So how do we get the CVMFS plugin to run? Is by running, in this case, we are using Helm, which basically automates setting up a series of Kubernetes, in this case, one deployment and one demo set. And we are passing it, so we are telling it where the Helm should find the chart to install this stuff. And we are passing a set of configuration file which we are providing. So let's go very briefly to this configuration file to see what we are doing. In this case, we are basically configuring the CVMFS-CSI plugin to work directly with EESSI. So we are using a direct proxy because we don't have a proxy set up in our server yet. We are passing it a set of configuration, which is basically what you will get in your etc CVMFS folder if you install EESSI following the standard procedure. So we are telling CVMFS where to find EESSI, where to find the key to EESSI, and we are also passing it the public key. Now, this stuff, how does this stuff appear in our containers? We need to specify some extra stuff here to mount these configuration maps into our container. I think this is easier to see once we go into the Kubernetes dashboard after we created the stuff. And we are also telling it to already create a storage class to expose our software.easy.io repository. And another variable that I want to point attention to is this auto mount hotspot, because as we will see, the containers we mount through the plugin will actually be visible to the nodes outside the containers themselves. So we can run the command to install the Helm chart, and I'm actually gonna get the dashboard so you can see in real time what is happening here. So basically, we are creating one demo set and one deployments, and these two are creating the pods and the replica sets under the hood. After everything is started, you will see here the stuff, everything becomes green, and we can actually explore a little bit what this plugin is doing under the hood. As you can see, the pod the pod of the controller plugin, as I mentioned, contains two containers. One, which is the provisioner, which is basically responsible for registering the CSI address to our system. And then the controller plugin, which is the one that is actually doing the control of the provisioning of the nodes and is telling the nodes, okay, go ahead and provision this system because you requested it with this plugin. In particular, all the containers that you will see that are not directly out of the Kubernetes one are all the same container from the CVMFS-CSI, and they're just exposing different commands. And if you are interested into it, you can actually go and see the Docker files under the CVMFS-CSI GitHub repository, and it's basically just doing a real kind of machine. It's installing CVMFS on top of it, and then it's exposing these binaries which are compiled through going from this command and internal directories, and these are all doing the implementation of the gRPC calls under the hood. We can actually also go and inspect the log of our container. In this case, you can see that we basically started the control, the provisioner, and now what we can do is continue the tutorial and create a persistent volume claim. This is, if you recognize if you're familiar with Kubernetes, we are just running kubectls through Minikube, and we are applying a configuration file. I can actually show you what this file is doing, and it's basically just creating a persistent volume claim. This is the name. We are setting it in read-only many so it can be accessed by multiple nodes at the same time. The fact that the storage is one, this is a comment you can find also in the documentation of the CVMFS-CSI plugin. Is not really used by the plugin, but it has to be there because it needs it to work. And then we are giving, saying, okay, use the storage class name, which we already created through the Helm chart, and this is pointing to the software.easy.io repository. So we can run this command on our shell. And if we go back to the dashboard, this is actually now doing stuff here. I need to switch just to refresh the thing. And now you can see that the provisioner actually got the request to create the persistent volume claim, and then the controller plugin actually forwarded it to the nodes, which are actually not doing yet anything yet because we are using them in an AutoFS configuration. If we were using it in a single man configuration, you will see stuff right away. So what we can do right now, and I can show you also now we have the persistent volume claim, and if you're doing this in an automated way, you have to wait that it reaches the bound status before you can actually use it. And what we can do right now is to create a pod that uses this persistent volume claim. We'll show you what is inside the file here. This is basically just creating a pod with an Ubuntu 24.04 machine, which is just waiting indefinitely. So it's just idling there until you kill it. And it is mounting our software.easy.io volume on the normal directory where you would expect to have easy. So it works as expected with all the absolute paths. And yeah, this is just the definition of the volume. So we can apply this configuration file. And as we will see, this is now creating a new pod, which is now loading. And while this is loading, we can actually go and see at the node plugin logs. And the register here will not tell us much, but we can see if we go to the auto mount container, this is the one that is responsible for mounting the CVMFS stuff to our system. And fun fact, as I was telling you before, this mount point will also be visible on your node directory. So I can do minikube SSH. This is to go inside the Docker container, which is our Kubernetes cluster node. And if you remember, we told it to put our mount under var CVMFS. In fact, if we go here, you can see that even outside of the node, this volume will be visible. Actually, this part is already working as an AutoFS, so if I were to do ls software.easy.io in here without it being mounted, it will auto-mount it. But this is done automatically when you mount the pods, the volume to your pods. And once we did this, we basically have a pod that has access to easy. So we can get access to a shell in our pod. This is how you will normally, similar to doing a Docker exec. We're starting a bash shell in our pod. But just to have less clutter on the screen, I will actually do this directly from the dashboard. I'm gonna go into my pod and gain access to a shell. And here we can see that we actually have access to our easy repository. So we can use our usual command to gain access to easy, which is to source the initialization script. And once we've done that, we can go ahead and clone the easy demo repository. We can go inside of it, go for example into the Quantum Espresso one. And here I'm gonna need a small trick to avoid having to install SSH and just another command that is boring to write by hand, which is to tell our communication manager that we're running on a single node, so to not try to use SSH to start the Hydra on other nodes. And because we are as root, we need to tell the employee that he can run as root. So we're gonna do run command. Here I'm gonna do for because it's we told the Docker container to start with for CPUs. The problem is that since we are running in a Dockerized environment, HWLock we still see all the CPUs of my machine, so it will try to run with 32 and kind of crash the calculation. Okay. And we can start our demo. So you can see we are downloading the pseudo potential, and here it's taking quite a while, but we will see this is because, as you might have seen in previous session, the CVMFS does caching. So the first time you run an executable, it's pulling actually all the files that you need to run it. And if I were to run it a second time, you will see this is gonna be much faster. And so this is basically an example to get the bus structure calculation of silicon. We can also, for example, try to run the PyTorch simulation, but I'm going to edit. All right. I don't have Vim, so let's install it really quickly. Okay. I just want to tell it to use only for CPUs instead of everything available, because this will definitely blow up on a machine otherwise, or at least the demo. This might take a little bit longer because it's pulling more files, but as we will see, then the caching is working. And while this is working, actually talking about the cache, I can actually also show you another part of the configuration that I didn't really go over, that I added recently for this demo, is that you can actually say where you want your CVMFS cache to be mounted on your machine, and you can tell the size of it. Here you will also have stuff to use the alien cache with the squid proxy if you have it. But in this case, I just the default cache was of 1 gigabyte. In this case, I said I wanted 10 gigabyte just to make everything work smoother. So you can see here the simulation is actually run, and if I try to run it again, yeah, it's run basically out of the right away. So let me think if there is anything else. I don't know. Should we run some more demos, or should we already open this for question? I think I went through it quicker than I expected, maybe.
I think for me that's good enough, but
Yeah, I think
quite
it's
impressive.
very nice demo on how smooth it is. I had one main question is what made you look into this? So what was the trigger to play with EESSI in the Kubernetes cluster?
Part of it, one of the partners in the project that I'm currently supporting, they're using, they have a modeling factory that uses Kubernetes under the hood. And even if it was not part of the project, we thought it would be much easier for us and for them to support the software in their system directly through EESSI. So I was looking into it. At the beginning, I was actually looking into the option 1 and option 3 because they had, I think, only 1 or 2 nodes in their Kubernetes cluster, so it made sense for them to just install it directly on the nodes. But then at some point, I was made aware that of the container storage interface, so I started looking more into better, more native solution to have easy installed. And I guess now that I think about it, going back to the starting part of the presentation, now that you've seen how everything works, you can see why I said that this option 1 and 3 are related to 4, because what the node plugin is doing under the hood, it has easy installed inside a pod, but it is mounting it into the basically root file system of the node, and then the plugin is making it available to all the nodes through the CSI interface. So the way the plugin actually works under the hood is doing this and this for you, but with the nicer side that only the CSI plugin has to have sysadmin capabilities, and all the containers that the user could start then do not. So if you like have a Jupyter Lab server and the user can just start instances on your Kubernetes cluster and get access to a shell, they will not have a shell with sysadmin capabilities that can then do stuff to your machine.
So CVMFS itself is running in a container in a pod.
Yeah.
But yet it's mounting easy on the host.
Yes.
Okay.
So they don't have to install anything on the host.
Yeah, no, you don't have to do anything on the host. It's all, I mean, just have the only minor things that you need to have a Kubernetes that is new enough to support running the CSI drivers. But beside that,
Okay.
And how new is new?
I don't know actually. I think I can see which one we are running here in the pods. I mean, we are at 1.34, so I guess it's should be
113 is recent enough. Yeah.
yeah.
Okay.
But
Yeah,
beside, I don't know unless you have a really old system which might have trouble with Fuse, but I haven't found anything, any mention of, of stuff that should be trouble on that aspect.
So how would you compare this with how things are typically run in a Kubernetes cluster? People typically grab containers from wherever and run the software from those. So
I assume, I never ran a Kubernetes cluster myself. I actually knew almost nothing about Kubernetes before starting this, but I assume that everyone manages their own set of containers. And I think one thing that would be really nice to have easy in a Kubernetes cluster, let's say you have a very distributed Kubernetes cluster that is running both on ARM and x86 machine of different kinds, then at that point you don't need to maintain your stack of optimized container for every architecture. You don't, even if there was a way to build them layer by layer, I think that would still be fairly a nightmare to manage. But here I would defer to people. If there is anyone here that actually runs a Kubernetes cluster and has comments on this, they would be welcome.
Yes, we are running a Kubernetes cluster, but that's only for machine learning and model training. But also there, everybody's pulling from the internet, and then because we have an NVIDIA full stack DTX system, the PyTorch they download doesn't perform well enough, and then you have to download a special one container from NVIDIA. So I think, and what I already said, if you want to do AI by scale, you need to know HPC. So this kind of stuff you need to know what kind of infrastructure CPU you have. And this makes it very easy to run an OpenFOAM version which optimized for your CPU.
Yeah, it takes away a lot of the time. As long as the software that you need isn't easy, it makes things a lot easier, it seems.
Yeah. Because there is also an OpenFOAM container, which just trying yesterday of last week with running with Aptainer. It worked with Aptainer, but I have no idea where it's optimized.
Yeah, it's probably built generically, so it works on any Intel AMD CPU.
Exactly.
It should be a lot slower.
That's interesting to see also. If you can
is that an official container or something that you found?
Yes, 2506 or some V2506. I don't know which branch from OpenFOAM that is, but
okay, yeah.
You have 3 or 4 branches of OpenFOAM, I guess.
Yeah. Well, I think nowadays
these are supplied by them.
Yeah, I think it's 2 forks that are really still active. But okay.
Yeah.
To go back to the Kubernetes thing, Davide, how much time did it take you? You said you were unaware of Kubernetes before, or hadn't
I had done like a small tutorial 2-3 years ago when I was job hunting, just to add something to my resume, but basically unaware of it. So it took me kind of a better part of a week. Spent 3 days bashing my head on because I was working with Kubernetes that I didn't know a lot about, CSI that I knew nothing about, and also CVMFS I didn't know really how to debug it in different contexts and the way we use it. And there was a small hiccup in the fact that the normal Helm chart, I didn't even know how to pass value to Helm chart, so that was my main problem at the beginning. But the thing that made me waste the most time when I tried to start the Kubernetes cluster in different contexts through VMs, to other stuff, because at the beginning I thought I was not able to access CVMFS repository because I was running within a Docker container and I had to do something more special, but it was just because the proxy they set by default in the Helm chart is not something you can access. At least I can't access this.
Okay.
So it was simpler than it looked, but it was not easy to debug when you were working with 3 systems that you don't know together. But after that, it was just optimizing.
This is just a hard-coded default that you're expected to change or customize.
Yes, basically, yes.
Yeah, okay.
Yes, that's always with the values.yaml. It's and is there also that they have purely the YAMLs to deploy, or do you always need a Helm chart? Because I don't like the package manager.
Yeah, I mean, you can also do what the Helm chart is doing by itself on your own. Basically, if you go and look into the templates,
Yeah,
what
okay.
the,
Then you have to. Yeah,
yeah, I
okay.
mean, you have to make your daemon set, which is basically running. It's Kubernetes entities that runs your
Yes, yes,
nodes
yes.
on every nodes. You have to make your controller plugin and decide where to deploy it. I assume if you have a more complicated setup, you might want to set node affinities and other stuff like run this only on this set of nodes, make this only available to this set of nodes. This is something that we might look into the future, especially if we start collaborating with people that run more complex Kubernetes clusters.
Yeah, because the Kubernetes people are still calling their Kubernetes a advanced scheduler. So, but they never heard of Slurm or anything else.
And
Yeah,
in topic of future stuff, I guess that is also, I mean, things that I think we should explore at some point is, first of all, we might want to make our own Helm chart on top of the CVMFS-CSI one. I don't know if you can install an Helm chart from an Helm chart, but in case we will just copy it and add stuff to it. And it is to directly give the option to install a Squid proxy inside your cluster and maybe even a Stratum one, which will make it work. I mean, in general, faster, depending where you're deploying. If you're running on AWS, you might not need to have a Stratum 1 because you're already close to the CDN nodes. But another things that I've seen mentioned in the Slack channel is what it might be nice for running easy when you already have easy on the nodes. Like if you have an HPC system that is already using easy. But it's actually not trivial, at least not in the way it's been done right now, to use it in an efficient way, because this will basically mount easy in a separate directory and use a separate directory for the cache. So we might want, if we see that this is a scenario that interests people, we might want to see if it's possible to reconcile and use only one mount of easy and the CVMFS cache shared from using easy directly from the node or from the Kubernetes pod running on top of it. And I guess another thing would be if people want to run, I mean, I've seen it's not straightforward to run internode stuff with K8s. The way I did it in my small test was to manually set up the host files and the SSH keys. I assume there are better way to do this, but once you do that, how do you deal with the host injections to run multi-node stuff on the cluster would be another interesting thing. And then is testing in the real world, so getting feedback from people that are actually running complex cluster to see how we can adapt and see how things works.
Yes. No, this is very good.
Yeah, nice. Thanks.
Very, very nice. And only 3 days.
Okay, other questions?
Okay. Like conceptually, it's actually relatively easy, right? You mount a certain VMFS repository in a pod. As soon as you get to that point, you should be done.
Yeah.
Because everything in the repository should work anywhere. It doesn't care if it's being run in a pod or native on a system. Yeah. From that point on, there's nothing special going on.
Yeah.
It's just reading files from a file system, and as long as you get the mount point correct, it should work.
Yeah, because Elmod is also inside the.
Yes.
Yeah, the container I started was a Beirut. You saw it didn't even have the teammates.
I think that is the big pro. You just have a Ubuntu container.
All you need is CVMFS to get access, and then you have everything you need. Everything is.
Yeah, but the CVMFS is provided by the site container.
Yes. So you don't need anything on the host. That makes it very powerful.
Yes.
Yeah. We have a question from Daniel. I can read it if you want. The number showed running it as root. Can you see any issues doing this in a situation where the workload pods cannot run root? For example, blocked by gatekeeper.
I'm sorry. Maybe I can also, because I didn't fully get everything.
I think the question is, does the pod need to be run as root?
No. It's here I just ran the user root inside the pod, but the pod was run without any sysadmin. The only thing that needs to be run with sysadmin capabilities is the sidecar containers that do the mounting for you. But then the file system is made available to your pods, and you don't need to be rooting it. I mean, here I was root because I didn't bother setting up another user inside the container.
Yeah, because in production that's never allowed to run as root.
Yeah, and in general, I would even recommend not to run easy as root.
Yeah.
Because it's really intended for user land, right? Not to be run root or to have services from there. Yeah.
Yeah, but I mean, even if you are root inside a container that doesn't have capabilities to touch the file system, I mean, it's not a security concern. It's just not great for, because then you need to do all those trickery to use MPRN and so on. It's not great in general.
Doesn't make sense.
Yeah.
Okay.
In security-wise,
Right.
I think as long as you don't give access to dev fuse, which is what this solves, I mean, unless there are vulnerabilities in the CSI interface itself, where there are exploits to do stuff with that, but that's a separate problem, I would say.
Mm-hmm. And next thing is to run Kubernetes on Android.
Yeah. Next topic, next talk, but not the 22nd, because I will be away for my birthday.
Sure. Okay. Other questions to Davide, or completely different questions?
This is a very nice proof of concept that's actually going to be useful on AI factories, for example. Some of the HPC AI factories are likely going to be running Kubernetes as well. So just the fact that this can be done and in a nice way with the CSI, with the driver plugin, whatever it's called, that's very encouraging. So just knowing that it works is very nice.
Yeah, and it's very nice that there also are already demos.
Yep.
So if in the end you have a picture with a Chromax or...
Yeah, it was Quantum Espresso and PyTorch, but really any software that.
Yeah, also the Chrome. I think the only one that didn't work was the bioconductor one, but because I guess I did set some networking stuff because it couldn't access the server to download stuff.
Yeah, but we see this happening with the bioconductor demo even outside of Yeah, so sometimes that server goes unresponsive. There's actually a way of fixing it. There's like a caching mechanism you can use.
Okay.
I think it has nothing to do with the setup here. We've seen this before. Yeah. Okay. Very nice. So the Android part is
very nice.
Another time, not the next one, but sometime in January.
Yeah. So next week we thought just have a sort of no topic really, but just meet and have a chat about EESSI, about our wishes. So we called it the EESSI Christmas topic next week. So if you have no vacation yet, or maybe if you have vacation and have time, join us also next week at the same time.